Hi all, welcome to today's session. In this session, we are going to deal with session 6 under Limits, Continuity, Differentiability, Engineering Mathematics Semester 1. So if you have not watched the previous 5 sessions, get back to the playlist, watch them so that you have clarity with respect to the concept and then come back. Before getting started, if you have not subscribed to my channel, please do subscribe and hit on the bell icon to get regular notification. Let's get started. Okay, here we have got an amazing problem. So chuck the continuity of the functions. Chucking the continuity of the functions. So when can you tell a function is continuous? There are two conditions. There are two different methods for telling a function is continuous. So the very first method is if the first order derivative of the function exists, then the function is continuous. That is one of the known method, which we would have learned in our plus 2 level. So we will use that method for some of the questions and we will see. So we know our f of x is nothing but 2x plus 3, right? Okay. And then we know f dash x. What is the derivative of x over here? 2, right? Okay. Now f dash 1. When x is equal to 1, the derivative will be 2 itself. Since f dash x exists, the derivative is existing, f of x is continuous at x equals 1. Continuous. Alright. Clear with this question? Yes. This is a simple question and easy marks gaining too. Right. We will go for the next question. So this is again the similar way. We'll take down the solution quickly. We know our f of x square. Find the derivative of it, f dash x, which is nothing but 2x. The function, the derivative at 0 is nothing but 2 into 0, that is nothing but 0. Alright, since the derivative is existing, since f dash x exists, therefore f of x is continuous at x equals 0. Clear with this? Simple. Both the questions are of the same method. You're solving both of them using the same methodology and same approach. Okay. Now comes the craziest question. So, are you remembering? Did we solve this question anywhere? Did we? Ideally, yes. In our session 4, we had this question. Alright. You can get back to session 4. I have explained it thoroughly over there. So, no matter. I will be explaining here also. Let me take the solution. I have my f of x. We are gonna convert this. I know most of you wouldn't have watched it. Get back to that. Okay, minus x and plus x. Minus x if x is less than 0, plus x if x is greater than or equal to 0. Now, find the left hand limit. Okay, so limit of the function f of x as x approaches 0 from the left hand side is equal to limit minus x as x approaches 0 minus is nothing but 0. Then we have RHL. Limit of the function f of x as x approaches 0 from the right hand side. Limit of x as x approaches 0 from the right hand side is equal to 0. So clearly, what can we conclude by this? Clearly, since our left hand limit LHL is equal to RHL. Okay, so we can tell limit of f of x as x tends to 0 is equal to f of 0, which is equal to 0. Therefore, f of x is continuous at x equals 0. Clear with this question? Yes, any doubts? No doubts. Okay. So in this session completely what did we learn? We learned about two methods to find a continuous function. To verify whether the given function is continuous or not, we have two methods. The very first method is find the derivative of the function. If the derivative exists, then the function is said to be continuous. And the second method, find the continuity of the function using the definition of continuous function. Limit of f of x as x tends to a is equal to f of a, which is equal to L. L is some value, okay, finite value. So then in such a case, the function is said to be continuous. Clear? Okay. So if you have liked this video, please click on the thumbs up button. Please do share this video. We will be seeing you in the next session, session number 7, with one more interesting and amazing topic over there. Till then, keep tuning with Akshay Manoj Official. Thank you. Have a nice day.